Hi, in this video we're going to look at the enthalpy of formation. By the end of this video you should be able to write an enthalpy of formation equation for any species that you're given. So let's have a look at it. So the standard heat of enthalpy, or the standard enthalpy of formation, or the standard heat of formation it's sometimes called. So it's defined as the change in enthalpy for the formation of 1 mole of the compound from its component elements. So remember, sometimes it's called the heat of formation. Now, what does the component elements mean? Well, if we look in this example here, we can see that the substance we have here, or the compound that we have here, is carbon dioxide. The two elements that are found in carbon dioxide are carbon and oxygen. Now, what we want to know is what are carbon and oxygen in their standard state. So if we were to find them at room temperature and standard pressure, what would be the states they were found in? Carbon is found by itself as a solid, in a singular atom, and oxygen is found as a molecule. So these are the elemental states. So these are what we would use to write the component elements that carbon dioxide is made from. In fact, there is a set of these that we need to remember. And here I've got carbon, hydrogen, oxygen, nitrogen, and chlorine, 5 of the most common elements we might use when we're starting out writing enthalpy of formation equations. Notice the carbon is formed from a solid, a carbon atom that is a solid, but all of the other elements here are diatomic gases. There are gases made molecules that are made of 2 atoms and are in the gas phase. So whenever we want to draw the elemental state for hydrogen, it's H2 gas, oxygen O2 gas, nitrogen N2 gas, and chlorine Cl2 gas. Okay, so once we know the elemental forms of the elements in a compound, we can write a formation equation. Now, sometimes when we write a formation equation, we might have to use fractions because of how we have to write the equation. And the equation always has to be written so that there is one. Let's have a look at how we might write it. Okay, so let's now look at writing some formation equations for some compounds. So I've just put to the right here the elements in their standard form. Remember, the carbon is a single solid particle, and the others as diatomic atoms in the gas phase. So the first one we're going to do is write an equation for the standard enthalpy of formation of propane gas, C3H8. So this is our compound. So we're going to draw an equation. So let's put an arrow in. And the first thing we're going to do is we're going to write our compound down as the product of this reaction, because we are forming it. It's a formation equation. The next thing we're going to do is we're going to look at the atoms that are in this compound. There are carbon atoms and hydrogen atoms, to work out the elements we're going to have in the standard form. So initially we're going to have a carbon solid, and we're going to have hydrogen gas, H2 gas. So this is a formation equation, but it's not balanced. And to make this a correct formation equation, it needs to be balanced. So let's now balance it. So if we look on the right hand side, now when we balance this, it always has to be balanced in relation to the compound on the right hand side. So there are 3 carbons, so I need to put a coefficient in front of the carbon here to make 3 of them. There are 8 hydrogens in the propane, so I need 8 hydrogens on the left hand side. Since each hydrogen molecule is an H2, I'll need 4 of those, and now this is a completely balanced formation equation. Let's have a look at another example. So we're going to write the standard enthalpy of formation for this equation here, which is for this compound, ethanamine. So again, we're going to put ethanamine as the product, and then we're going to identify the elements that make it up. So we've got carbon, that's carbon solid. We've got hydrogen that comes in the hydrogen gas, H2 gas. And we've got a nitrogen, and that's going to come in as a nitrogen gas. Now, what's important, and I kind of said about it on the previous slide, is if this is our compound that we're forming, we now have to work out exactly how many of the atoms we need. And for the hydrogen, it's 7. There's like H5 and there's another H2 there, so that's 7 hydrogens in total, which means when I'm working out how many hydrogen molecules I need half of 7, which is 3.5. And it's perfectly correct to use decimals or fractions to tell us how many of each we need. So we need 2 carbons, 3.5 hydrogens, and notice we have 1 nitrogen, so we're using half a nitrogen. So you can either write 3.5 here, or you can write 3.5 or 3.5, or you can write 0.5 or half. Okay, so let's see if we can practice this with the final piece of slide I have here. So now what we're going to do is you are going to practice writing these enthalpy of formation equations. So on the left hand side I've given the of this table here, we've said which are the compounds we want the enthalpy of formation equations for, and what I would like you to do is just use the wee table on the right to work out the elements in their standard form and write the formation equations for these 5 different compounds. So remember, you're going to just pause the video now, you're then going to write the answer, and then I will go through the answers. Okay, so let's go through these answers. So the formation equation for water, of course, water on the right hand side, we've got 2 hydrogens, so it's an H2 plus half an O2. The formation of carbon dioxide on the right hand side, we're going to have 1 carbon atom and 1 oxygen molecule. The next one we have here is propanol, so we've put that on the right hand side. There are 3 carbon atoms and 8 hydrogens, so 4 hydrogen gas molecules and half an oxygen molecule. Remember, because it says it's the formation for one of these, I need to make this a half or a decimal. I can't sort of make everything whole numbers and make this a 2 at the end, because it has to be the same as it's written. The next one, see this? It's carbon gas. So this is a bit confusing for a start, but if we look up here, we see the actual standard form is carbon solid. So we can write an equation for this, and it's carbon solid going to carbon gas. And the last one, we've got some type of chloropropane here, and here it is on the right. So we've got 3 carbons, 3.5 hydrogens, and half a chlorine. That's quite a big half for 3.5 hydrogens. And that's how we write enthalpy of formation equations. Hey, look out for the other video I've got on how we write enthalpy of combustion equations, and I'll go through those. You can practice those as well. Good luck.